Hello everyone, my name is Arun and welcome to my channel. This series is a series of tutorials on C programming, and in this tutorial we will continuing with the program that we saw last time. And now in this part of the program video we'll be doing some basic arithmetic operations in this program. So what I have here is that I just in the last video I explained the different types of data. There are different data types available in C. Some of the basic ones like the integers, the floats, double, character and boolean. And now we're going to do some arithmetic operations with them and to show some of the differences they have and what can be done about it. Now here's the thing, just to give a quick recall, int is actually used to store integers, that is the numbers that do not have any decimal part in them. Float is stored for storing numbers which have decimal part in them in contradiction to integers. In contradiction to integers, but the only thing is that it has only 4 bytes of memory in space, so the precision is actually limited to 4 to 8 digits. Okay, on the other hand, double stores takes twice the memory of float, and it has more storage facility and can store even larger ranges of numbers and has higher precision, but it's relatively slower compared to using floats. Okay, character is used for storing 1 byte of memory. It takes 1 byte of memory and stores numbers between 128 to 127, or it can store a single character. And boolean is actually the true or false variables, okay, that can store either 0 or 1 or true or false. Okay, now let's look at some operations. Now I have int i1, i2 and i3 over here. If I want to assign a value to integer like this, I can assign like this. For instance, i1 I can set it to 5 by using this equal to operator. If I want to set, instead of 5, I want to set this to be like 56 or something, I just subtract the number and that will do. Alright, similarly now here I am setting i2 to be 20, and now what I can do is to just add i1 and i2. All I have to put is I just have to put an assignment statement like this. I3 equals I1 plus I2. So this is actually a mathematical expression. In technical terms, in computer science terms, okay, or programming terms, whichever way you put it, this is actually an expression. What it does is that it takes an operator which has some kind of inbuilt functionality, and it joins two operations in two variables and does some kind of an operation on them. So since addition, this plus operator actually does addition with the values stored in i2, i1 and i2, okay, and it's assigning that to some other variable over here. This is a mathematical expression. Okay, that's how you go about it. Or sometimes if we just drop this word mathematical and we just call it expression. Okay, and this is how we do addition. For subtraction, you instead of plus I can put minus sign, and that will do for subtraction. Okay, and likewise I have two floating numbers over here, and I can do the same thing as above. Similar thing as above, I can do addition, subtraction and all. And if I want to multiply, I have to use this asterisk symbol over here for multiplication. Okay, so if I write f3 equals f1 star f2, it means f3 will be equal to 5 multiplied by 20.46 as per this expression over here. Likewise, if I want to do a division, I can do a slash as well. That will work. That will perfectly work. Okay, and this is the symbol for division. And likewise, you can do more with that. And this is a subtraction. And let's run about with this. First I'll just compile this program. Okay, no errors, no one is going to run this. Let's look at the results. It says the sum of 5 and 20 is 25, and this term comes from this line over here. Likewise, the subsequent term, the product of 5 and 20.4999 is 102.29995 something. Okay, this line comes from over here, and I think it's about time I explain what's happening over here before we go on further. You see, I'm doing addition operation over here, and I want to print out the result. Okay, I can use the printf statement like this. What actually happens here is that I'm taking printf statement, and then I'm putting this massive string over here. Remember, printf statement prints strings of output on the on the screen or the terminal. Okay, and now here I want the values of I1 and I2 and I3 to be placed inside the string. Now, one way, since I cannot break this string, okay, printf statement only accepts one string. Okay, so I cannot write this in multiple lines. The one way I can do here is I use what you call as a placeholder method. What it means by that is it's kind of like booking a reservation in a train or a movie. Okay, what do? You cannot go there and directly book a ticket. Okay, book a ticket. So what do? You just book a ticket in advance and get a seat number so that when you come, okay, when you come for the movie or come to the train station, you can directly go to this allocated seat for you so that nobody else can come. It's kind of like that. What this placeholder method does is that, okay, you assign some kind of symbolic value, okay, that acts as a kind of a placeholder for your value to go and sit in. For instance, this %i acts as a placeholder to put integers inside a string. So whenever this %i comes inside a string, okay, the compiler will know, okay, I have to place an integer over here, and which integer should I go for? I just look into the data stream after the end of the string. So this is the string and this is the data stream, okay, because this contains a stream of data one after the other. So what it does is it will print the sum of as it is, and instead of this %i, it will take the value of this integer and it's going to place it over there. Since I1 is 5, it's going to, instead of this %i, it's going to put 5 over here. Okay, and then it will print and instead of this %i, is going to print the value of I2 over here. Since I2 is 20, I20 will be coming over here. And then it says is, and then this %i, instead of this %i, the value of I3 will come over here. Since I3 is 20 plus 5, 25 will come over here. Hence the the string that gets printed is the sum of 5 plus 20 is 25. Okay, similarly, if you want to put a floating value inside a string, the placeholder, you have to use the same placeholder method, and the placeholder for this is %f. Okay, so what happens is that here in this statement, if you look at it, it will print as the product of 5, because %f stands for float. So the first float value I kept as f1, so f1 will come over here, f2 value will come over here, and f3 value will come over here. So it will say the product of 5 and 24.46 is 20. I mean, the product of these two will come over here, which is at 102 points, 103 something ish. Okay, this is likewise in the subsequent statements for this double. Okay, it's going to do the same thing. The division of 5 and 25 by 20.46 is, and the value will come over here. Okay, and that's how we do it. And these things have a notation. This %i, %f, %g, okay, %f again. These are actually called as format specifiers. Okay, they serve for two purposes. One, they tell the compiler about what kind of a variable data is going to be present inside strings in the printf statements and scanf statements, which will come across in a future tutorial. And also it will tell the compiler as to how to interpret the data, like how to present the data, like should I put trailing zeros should I put leading zeros, or how many trailing zeros should I put, or in what kind of a format I want to write the numbers and all, or represent numbers and all. That will be taken care of by these format specifiers. Okay, so we'll be looking in detail about format specifiers in a future video, but this is just to get a head start. Okay, so the format specifier for integers is I. In some cases and in many cases, in the olden days, people use %d for it. The format specifier for float is %f, which is intuitive, and for double it is the same %f. In some cases, people also use %g and %e, and they just have a slightly different notation of how to present it. Okay, we'll look about this in detail in a future tutorial. And for character, okay, for characters you can do this in two ways. If a character variable, let's say C1, stores a number, let's say they store a number. If you want to print those numbers, you have to use the place. You have to present the place. if you want to represent the numbers and print the numbers out, you have to use percentage D. Okay, percentage D or percentage, even I would percentage I will also work. Okay, but if you want to represent them as character, you have the placeholder value is percentage C. Okay, that's about it, and that's why it says the characters 1 and 2 are, instead of percentage C, C4 value will come, C4 is assigned to Q, and C5 value will come over here, which is this right closing brackets. And here's the notation. If you want to assign just numbers within minus 128 to plus 127, it's very straightforward. You can just assign them directly, it will work fine. On the other hand, if you want to assign character to a character variable, it has to be in single quote. Okay, it has to be in single quote, that's mandatory. If you put in double quote, it will become a character array, and that is a little higher data type, and that will come across in the future video. Okay, and finally our last simple data type for today is the logical character, logical variables. Okay, logical variable, if you want to assign logical variables, the values it can take are either true or false. Okay, instead of true I can also write 1, instead of false you can write 0. These are the numerical equivalents of these true and false statements. Okay, and if I want to print them up on the screen, I cannot directly use true or false. Instead I can use the numerical equivalents, and to get the numerical equivalents I can use percentage D. So thereby if I run this, the value of B1 and B2 are percentage D, it will print out as 1 and 0. Okay, now if I compile this and nothing, so if I run this, there we go. The sum of 5 and 20 is 25. The product of 5 and 20.499 something. See, this is the thing, as I told you earlier. I told you, right, sometimes data will not be properly represented by float and all. Okay, that's when double comes in. Sometimes if the number is not completely representable, let's say, okay, which happens in float sometimes, double has a better chance of representing them properly. And that's why the number 20.46 is almost approximated to this, because while representing the numbers it's a little tricky and it doesn't come out well in float, whereas in double it came out well, so the number came out precisely. Okay, nevertheless the computational error because of this would be very minimal, so you don't have to worry about it too much. Okay, but on the other hand, if you're very sensitive about your calculation, you have to look for a higher data type to make sure that your errors because of this number issues, they do not affect much. Okay, and the results are coming out, and the difference of 50 and 20, remember 50 was a character variable C1 and 20 is a character variable C2, is 30. Okay, and likewise the characters 1 and 2 are Q and the brackets. Okay, the values B1 and B2 are 1 and 0. They're turning out to be fine. Now if I press enter, this will close up. And now that's all I have for you guys in this video. This is like a quick coverage of some of the common arithmetic operations, like basic arithmetic operations and data printing with basic data types. Okay, the next video I'll actually come up with next video we'll be doing an actual application wherein we'll be taking data from the user, and we'll be calculating the area of a triangle using Heron's formula, and that will be a little fun. Okay, till then, have a look at this program, try to change these values, and play with this. Get yourself comfortable with it, because the next program it's going to be slightly interesting, a little more challenging. So if you're comfortable with this program and you're good to go, you can watch that video. That will be fun. Okay, so thank you guys for watching, and I'll see you guys next time.